So what I'm going to do in this video is go over the problems on the recitation that we have skipped over. These were all chapter 9 problems that we haven't yet worked on in recitation. So there's 4, 7, 8, 9, and 10, and these are all posted under the chapter 8 materials, I think, with the chapter 8 recitation. And so we're going to start at the top and work our way down. So the first question has a heavy ball suspended by a cable. I'll let you read the question while I get this set up. So in these videos, I'm going to make references to times that you should pause and try the problem on your own. And this is a good time to do that. So I'm going to go straight to the solutions, so I'm not going to give you time to work on the question. So assuming that you've gotten started working on this, the answer to this is C, which is that the force is equal only to the X component of the tension in the cable. And the way that I think about this is by drawing a force diagram. So there's 3 forces acting on the ball. I have this force to the right here. I also have the weight of the ball, and that always points down, so I'll call it Fg. And then we have this tension force, Ft, that pulls up at an angle, just like that. And if we are using the condition of static equilibrium, which is really in this case just the condition of Newton's second law, we're going to say that all of the forces equal 0. We could also use that all of the torques equal 0. But since this is an object with just, that's just basically a dot and all of the forces are pulling out at one dot, there are no torques in this problem. It's just a sum of the forces equal to 0 problem. And this would be something that if we were to problem solve for this, we would split it into the x direction and the y direction, as we've all become quite used to doing. And then I would divide this into the x component of Ft and the y component of Ft. And I see now that I haven't done a very good job of drawing these forces to scale, so I'll make this one a little bit shorter so that I can see that in the x direction I have 2 forces and they have to cancel each other out. So I would say that F, right, this force right here, minus Ftx has to equal 0. So that is why the answer to this is C. So this force here is only equal to the x component of the tension in the cable. So it's not really even a new problem. That could have been a question that happened in chapter 9 or in chapter 4 as well. We're just adding to the conditions of equilibrium now.